as a collaboration of Wageningen University Research and CGIAR's Asian megadeltas. In this series, we already have had quite a number of interesting presentations. The objective is not that the research should be kind of fully polished and complete, but the objective is to learn together by sharing about our research. A big welcome to everybody from the Wageningen side, and I'm handing now to Katie to do the welcome from the AMD side.
Yes, thanks everybody very much for joining us today, and I hope you have been on our journey over the last 17 Delta talks that we have had, or last 16 as well. So it's been a pleasure to be organizing this together with Wageningen, and this particular research that is going to be featured today is a collaborative effort between CGIAR together with Wageningen. And I am delighted to have some very exciting news that one of the presenters also has recently just defended his PhD. So Feroz, congratulations. And yes, I think we can go ahead and jump right off. And let me just check the agenda for today. Oh, it actually isn't listed who will go first. So I will let Feroz go ahead and please, if you'd like to introduce yourself also to the group, and then we can go ahead and start. And we'll have time for questions afterwards, so feel free to put your questions in the chat box and then also write them down so that we can have time for questions at the end.
Thank you for the introduction of the meeting. I'm Feroz Islam. I work with the Wageningen Environmental Research in Water and Food team with Catherine. I'm a hydrologist, and as Katie said, I just defended my thesis last week. But I think today the presentation will be given by Marijn and Angel, and it's about a project that we're working on. So I will give the floor to Marijn.
Okay, apologies there. I didn't see Angel in the room, so I wasn't sure. And then Marijn, you were on the second page, so I only have seen Feroz at first. But thank you.
No
yes,
problem.
please.
I expect Angel still to come, but I can start. Let's see by sharing my screen if everything works. Do you see my screen?
Yes, it's not in presentation mode though. Yeah.
So now it is?
Yes.
Okay, I don't see you anymore, so I hope everything will be okay. So thank you for the introduction, and I will indeed present the work that we have been doing together with Catherine and Anton, and it's on upstream changes and the downstream effects. And this presentation will focus on the climate, water and food security in the Mekong River Basin. So thank you for joining today and being interested in this talk. Before I discuss the study, I want to introduce ourselves or this project. So it's indeed a collaboration between the International Rice Research Institute and Wageningen Environmental Research as part of the Asian Megadeltas Initiative. And from IRI's side, we worked closely with Catherine and Anton and had many discussions and feedback rounds together. And from our side, from Wageningen Environmental Research, Hester, Feroz, Angel, Catherine, and me worked on this project. And the project had two main outputs. One was focusing on salinity, and that's indeed led by Feroz. If you're interested in that, we will not discuss it today, but I think you can always reach out to him. And the other part of the project was focusing on the interaction between upstream and downstream. So that's actually was the research aim. So we studied the link between the upstream regions and the downstream delta now and in the future. And by studying this, we really focused on the water food system. So we looked at the water use upstream or the food production upstream, and what this may have from implications downstream. We did this for 2 basins, for the Ganges-Brahmaputra-Meghna Basin and the Mekong Basin. And as I said, in this presentation, I will mainly focus on the Mekong Basin because the approach is quite different. So it will be quite complicated if I show them both. And I think the Mekong already in itself has enough to share. I think we will do questions in the end. So I'm not sure if that's how it normally goes, but you can always, if you have a question, write them down. So some context, the Mekong River flows through 6 countries, starting in China and flowing into the delta in Vietnam. And it's the home of more than 65 million people. And regarding food security, it's the 3rd largest rice exporter of the world. Most of it is produced in the delta. And I think therefore we can actually say that it's the rice that's produced is important for the food security within the basin, but also outside the basin. And it's a biodiversity hotspot. And I think with more than 1,300 fish species, also fishery is quite important for the food security in the basin. So this is some context. There's probably way more to tell, but regarding the time, I would keep it to this. So what did we do to study this linkage between upstream and downstream? We used the hydrology vegetation model. It's called LPGML. We downscaled this model because we normally use it at a global scale, but now since we look really on these specific regions, we downscaled the model from grid cells of 50 by 50 kilometers to grid cells of around 9 by 9 kilometers at the equator. By downscaling it, we also already updated with the newest available input data. So I will explain quickly the model to you and also this input data before I jump into the results that we found. So how does the model actually work? It's not, this slide is not super technical. If you're interested in the technical side of the model, there I put 2 references here. I think this presentation will be shared later, so then you can always look it up. But simply said, there's some input data that goes into the model, and then the model simulates the hydrology and also the crop growth and the vegetation growth over time. And we do that by having some input data regarding climate. So precipitation, temperature, and radiation are really important, and that's on daily time steps. And at the same time, we include land use to the model. So we have agricultural area for 12 different crops, including rice, wheat, maize, and we also divide them between irrigated and rain-fed crops. We included also the location of reservoirs and dams and their capacity, and the irrigation canals are also included. And then regarding the crop, we also forced the model to start growing certain crops on a certain date. And then based on the heat units, the crop will be harvested. Then what comes out of the model per grid per crop, and it's also on a monthly time step, so it's spatial and temporal. We see the water availability, so the discharge flowing through the river, but also the local runoff, irrigation water use, the exchange of water by evapotranspiration, for example, and of course the production and the yields. So this is a bit simply said what the model can simulate and based on what input data. So as I said, we downscaled the model from global to regional, and this gave us the opportunity to fine-tune the assumptions that were made in the global model, and to really see what is important for the Mekong to be included. And I think on the top of the list was the double cropping of rice. So the global model only has one season of rice per year, while actually in the Mekong this is even tripled, I think, in the delta. And this changes the water withdrawal patterns significantly throughout the year. So that was on the top of our list. Also, we updated with a new data set on reservoirs and dams, and we included the irrigation canals in the delta because we also thought that would be really important to actually simulate the water system accurately. So I will explain these 3 points with some figures. So this is the data that we use, for example, for the double cropping. In the 3 maps, you can see the sowing dates of rice. And as you can see, there is triple cropping in the delta. So there's one sowing moment in January, then there's one in May, and later on one in September. And also upstream of the delta, you see that there's double cropping in most of the countries. I wanted to include also this pie chart because you don't see that in the maps, but the agricultural area, so the amount of area that in total is there to produce rice. So if you do triple cropping on one plot, we summed that area in this pie. And then you can see that Vietnam has the largest agricultural area, followed by Thailand and Cambodia. So this also shows the importance of including these triple croppings for the agricultural area. So that is the double cropping or triple cropping in the delta that we included. Then some information on the reservoirs and dams. In the map, you can see with the orange dots where all the reservoirs are located. And there are 2 large ones here upstream. I'm not sure if you see my mouse. I will use this one, the laser. Here, there are 2 large dams. And you can also see in the graph that the capacity of dams is increasing towards 2020. So I assume that this is caused by these 2 large dams, probably. And we find it really important to be included in the model because there's the reservoirs have an influence on how the flow is changing regarding the natural flow. And then the last point that I want to show you before I go into the results is the implementation of irrigation canals. So this is the delta, and as you can see in the light blue lines, these are all the canals. And normally the model will take water from the neighbor cell if it doesn't have water in its own cell. But now we said that in this delta you can also get your water from the place with the red arrow, so that it's actually more accurate where the water is coming from. So that was what we did, and then we ran the model with this new input data, and we did it for the historic period. So that is a 30-year average from 1981 to 2010, and to the future period. And then we took the average between 2036 and 2065. But first, we also needed to have some climate data to as input. I want to show you this quickly because I think the climate data which climate data is picked is really important for what the results show. So we took regarding the future, the SSP 370. This is a scenario between RCP 6 and RCP 8.5. So I think quite assuming increase of greenhouse gases by the end of by 2100, it will be doubled within this scenario. And what you can see in these figures is that especially temperature change will be taking place in the northern part of the basin, so here. And both precipitation will increase in the delta in this scenario and also in upstream a bit, while in the middle of the delta, you can of the basin, sorry, you can see a decrease of precipitation. So that is the climate data that we use to force the model towards the future. And our first finding was actually that there's a large effect of CO2 fertilization because we did not include any land use change towards the future. So we kept that constant. And still we found that there's quite a large increase of production. So that's on the left side. You can see per crop that most of the crops have an increase of their production, both in the delta as well as upstream. And this is mainly caused by CO2 fertilization. It can also be caused by a bit of temperature increase and that the radiation is more optimal for some crops. But CO2 fertilization has a big influence on this. And this is also found in other studies that rice yields gaps may be closed more towards the future if with these CO2 increases in some places in the world. At the same time, we saw that the water withdrawal is decreasing towards the future. So that is the blue line is the future and the orange line is the historic period, both in the basin as in the delta. So actually the production is for most crops increasing, while the withdrawal is decreasing. Probably because plants can be more efficient with higher CO2 concentrations. So what effect does the future have on the flow of does the future climate have on the flow and the reservoirs? First, we looked at the natural flow. So this is without reservoirs, and we saw that there's especially an increase during the drier season in the future, and that it's decreasing during the monsoon season, and that is so that is here the dry, and then here is the monsoon period, and that the highest peak is a bit later, but also a bit higher. So this can also affect maybe the floodplains in Cambodia if they are flooded and the natural flow is actually already lower. This may have some impacts there. We also compared the actual flow with the natural flow, and we saw that towards the future it's more extreme, the difference between the two. So in the dry period there will be a higher actual flow than, so that's this line that is shows an increase of inflow, and this is caused by these reservoirs that let go certain moments the water, and then there is a larger flow compared to the natural flow. But also during the monsoon period, there is a decrease of actual flow regarding the natural flow. So what does this mean for the delta? Therefore, I have these two figures to show. On the left figure, you can see the withdrawal in the delta in the bars, and also the actual inflow towards the delta for both the current period or the historic period and the future period. And what you can see here is that the withdrawal is the highest in the dry months, but also the lowest inflow is at this point. So this is the I think the highest dependency on the upstream water. With our scenario, the inflow will increase and the withdrawal will decrease. So that actually would mean that there is a lower dependency on the upstream water inflow, and that is shown also in this graph, where we have the actual inflow compared to the actual withdrawal compared with the actual inflow, and we created a kind of indicator to show the upstream dependency. This graph also shows that actual inflow dependency of upstream dependency ratio will be lower towards the future. And we find this really interesting. And also we could see that these dams have quite some impact on during the dry season. And at this point, it looks maybe more like a positive impact for the delta inflow. However, we also would like to highlight that the system looks quite sensitive towards these changes. So if there's other type of management of the reservoirs and dams, it can also increase the water the upstream dependency a lot. And also, we did not look at that, but I can imagine that this also can affect floodings quite significant. So what does this mean for Mekong's future? I think based on our results, we may say that the food production may increase because of CO2 fertilization. The discharge patterns can change and can also increase the vulnerability of the agriculture in the delta and midstream during dry and monsoon periods. And this depends on how the reservoirs and dams are managed. So the impact of reservoirs and dams looks quite significant, and it's also I did not show this in the results, but this is really something that I would also like to highlight. Is, as I said, this the basin is also has a rich it's a biodiversity hotspot. Fishery is really important as well. So these change in flows can also impact ecosystems and the fishery sector. We did not change the land use, and I think also that can still significantly change the inflow towards the delta. So to conclude, with our study, we took the first steps to simulate the water and food system of the Mekong with this model by downscaling it, but also updating it with new data. And I think it's really important if you want to understand the upstream, downstream systems and how they are interlinked, that the data need to be detailed and also adapted to the context. Like, for example, these cropping patterns. And then I would like to highlight some next steps. We still have to calibrate the yields, and we want to do that on subnational scale if we can find the data for it. I would be really interested to also include other climate scenarios, maybe one that is having less CO2 increase towards the future, to see how big that effect eventually is, or what the sensitivity is of the system regarding this CO2 greenhouse gas emissions. And as I said, I think it's really important for this study to also have land use change scenarios. And I think these need to be developed with experts in the field to get a greater picture of the system, and especially what the future will bring to the Mekong River Basin. Then we are also, a small last point is that we are now making a research brief, which will be published soon. So if you're interested, maybe Catherine can also explain where it can be found. But if you're interested, you can maybe also send me an email and I can share it later with you. So here's also my email. And this research brief also includes the results of the Ganges-Brahmaputra-Meghna Basin. So that was actually my presentation, a bit more over 20 minutes. I think I can stop sharing.
Thank you very much, Marijn.
Oh, is there some additional slide?
I don't know if you can see the clapping that is kind of sent by the audience to you in virtual way.
Thanks.
Extremely interesting. I think that there may be questions. I did not see any questions yet in the chat, but if you could kind of raise your hands if you would like to ask some questions for clarification or for kind of follow-up questions, we will take the questions as they come. Katie, please go ahead.
Yes, thank you so much. This was an excellent presentation and you covered a lot of material. So my question mainly was on your last point where you talked about like working with experts to discuss land use scenarios. And so I'm curious if in the sort of next phase of this, we could consider looking at what some of the future development plans that are in some cases already planned out or already available in the different countries. And particularly one I had in mind is that I recently heard that there is some large infrastructure developments planned in Cambodia for some canal infrastructure going out to the coast, and that this will affect the downstream water availability quite a lot, which would then affect the entire sort of Mekong Delta region in Vietnam, which requires a lot of water for the rice production there. So yeah, maybe I would be curious to hear what that would look like in terms like of bringing together stakeholders from government levels and experts, and then what we might how we might consider that for using these as tools to look at what those land use changes, how they might affect flows.
Yeah, I think also your point on this canal is really important. I did not include it in the presentation, but I also read about it that that this can indeed just take a lot of water that actually normally flows into the delta, and also will increase probably the irrigation area in Cambodia. So that is indeed something. I did not really think about yet how we would do this, but I think to have a base of some literature that we can find to for example, to have these canals, and then have a discussion with governmental institutes, researchers, and see which are the most important to include, and make also the ones that are more certain. Maybe also make a second land use scenario to also have some sensitivity analysis there would be good. But I think having these workshops, first having a base with some scenarios that we already have in mind and then adapting them would be really interesting.
Great, thanks. And just to let everyone know, also the research note will be available on CG Space, and so we can also share that with the emailing list here once it's published.
Oh yeah, that's maybe better. Yes, thanks.
Okay, thank you very much for that question. Paul, you also had a question. Please come in.
Can you hear me?
Yes, please.
Yep. Okay, great. Yeah, that was a great talk. Very interesting. Slightly surprising outcome, actually. So thanks very much. Really good work. So in terms of that, more water in the dry season, does that mean there'd be less salinity intrusion?
I think, Feroz, you can answer that the best. I would say yes, but
Yeah, it depends on a lot of things. Huh? So not just upstream water availability, but also what we explored in our salinity is 8 different drivers of salinity. One of them is sea level rise as well, and land use change. So yeah, it might have what we see as well is like availability of fresh water from upstream has a positive impact on lowering salinity, of course. But there are other factors which actually increases salinity. So there has to be a how do you say a combined impact, and that needs to be assessed to say certainly that okay whether salinity will increase or decrease. But yes, I think it will have a positive impact with the freshwater flow increasing.
Okay, cool. Thanks, Feroz. Just really sort of following on from Catherine, I think the land use, changing land uses is really important. I think what you've got now is really good. There's a lot of change in the Vietnamese Mekong Delta, things like fruit production, changing away from rice, even all the aquaculture, shrimp and things like that. So there's lots there. also mentioned about canals in Cambodia, and I know on that map of your planting times, there's very little in Cambodia, or relatively little in Cambodia, even less in Laos, and whether that will change over time. So more, and also intensification, extensification of existing crops. So there's plenty to chew on, and that would be really interesting. Sensitivity analysis of the dams, those big 2 dams, and they just jumped up. So I think that's, I think the China's going to keep going for it. And just one more thing, I suppose, is can this model looks really good. Can it be sort of sent out to various unis or research agencies in countries, in some of these countries, whether it's India, Bangladesh, or Vietnam, and sort of tried to be utilised, or just to get it, if it sort of seems good, because some of the work you won't be able to do all the work yourself. So can it be decentralised and taken up in a...
Yeah, the model itself is open source. However, it took me quite already a lot of time and intensive training to learn how to at least run it. And then I did not even change any of the code. So I think every university could use the model. Also, if we finalize this the downscaling 5 to the 5 minutes, I think this will be also again shared. But I would say that it takes quite some. It's not that user friendly, I would say. And I also really liked your point with this intensification, because that's also not included in our scenario. But of course, also the management of land will change, which can also have quite an impact on production and also water use and irrigation changes. So this is something that is still also necessary, combined with the land use change. Thanks for making that point. But you can still look up these 2 references that I shared in the PowerPoint. I can also include them in the chat. Then you can find more information on the model, and then there's, I think, also the link to where you can find all the code.
Bringing in a way together what both of you are saying, because from Paul's point, and that there's the importance for linking to the local scale level. Ryan's point that yes, we get new insight by using this global model at a regional scale with adjustments, as she explained. So, Marijn, could it then be such that for doing such a next step, it's not necessarily actually that you have to run the model even at a lower scale level, but you could also kind of bring it together with other models that may be existing at that lower scale, or with observed data at a lower scale level? What would be your suggestion?
Now, I think indeed, if you know, for example, that this canal will be built towards the future, and you have some information on how much water will then be flowing into the canal instead of following the Mekong River to the delta, you can also use our discharge data and then see how much less will it then be, and will this come to the point where you actually reached the same. Yeah, I will share quickly my screen, because then you can actually see here, will you maybe then reach the water withdrawal in the delta and the inflow, and then this upstream dependency will increase a lot. So there are some I think with new numbers you can already look the data and combine them without again running the model. However, I think it's interesting by running the model, you can also already see the impact on the food production, because that's then the next step. The model then calculates how much food will be produced from which source of water it will take. So that will be then the added value of using the model again. Yeah.
Okay, thank you for that question. Wise, you also have your hand up. Would you like to come in with your question?
Frankly speaking, previous discussion clarified many of the my questions, but only I love to learn from the Mekong Delta study how it relates with the delta in our area, like Ganges Delta. Anyway, we'll be waiting
Okay.
to.
I just interrupt you for a moment, Wais, because this is an important question. And like Marijn indicated in the beginning, the work was done both for the Ganges Brahmaputra Meghna as a basin and delta, as for the Mekong basin and delta. But because we had earlier delta talks already focusing also on other aspects in Bangladesh, for this presentation, Marijn focused on the Mekong delta, but the research brief that is being prepared will be about both. So yes, you will get your information, a lot of things to study. Please continue your question.
No, that's fine. But only and my further question is, you talked about the canals. How the canals are maintained in the situation like conflict of rice and non-rice, for example, crop and fisheries. So there could be some conflict, and there could be some dimension of conflict management in canal water distribution or control.
Okay.
Yeah, that's a good point. And this then I guess will also block some of the canals. Is that what you mean?
Yes.
Yeah.
Yeah, and I think that's a Dr. Kabir, that's very important, because right now in the LPML we assume that the canals are working according to the theory, so they are distributing water from the inlet to all the points. But of course, when you really want to assess like a sub-regional analysis, you really need to consider, let's say, the water operation in the canals, if really those canals are working well, if they are really providing water to everywhere or more water to one side to the other. And that's something that the model can do, no, Marijn? Just entering blocking canals or reducing the water availability in those canals. So that's something that can be done, but we didn't enter into this yet. So I think for our next step can be also important.
I think it's interesting, but for the aim of this study to really understand the upstream effect or the upstream impact of the impact from upstream, this maybe be too detailed for this model, and maybe other models or maybe just discussions and literature are maybe more interesting to see. But the reason why we implemented the canals anyway is because otherwise the model takes groundwater, and therefore we would be too afraid that the groundwater will be overestimated. So, but I think your point is really good, and I think this is something we definitely at least need to mention in the discussion, that we assume clean, well-working canals, while this is in reality not the case.
Thank you.
Thank you for your question, Wais.
Yes.
Do you have further question?
No,
I see Marianne. Oh,
we'll
sorry.
be getting it back.
Okay, then I go to Mariana, who also has a hand up. Mariana, please come in.
Yeah, thank you, Marijn, for presenting. And we have already discussed many points. I would like a bit to follow up on few and bring in something new also. So with the seawater intrusion, I was also wondering, how or whether you can sort of take into account that it's not only intrusion, but it's a seawater level rise. So that makes also then the system different. So that plays then also into it, I assume. Then we already talked a little bit about reservoir management, but still I think maybe even reservoir management is more important than land use, as if the management is changed, so it can just completely change the flow of a river, depending on what for the reservoirs are used, and what the decisions are of the people who steer the reservoir. So that is so I'm wondering, so how good the data is that is available for really model this management, and also how the model can be used, or I assume maybe there are other sort of partial models also already existing. How to deal with then the water quantity. And my last point, and maybe I missed something in the presentation. At the beginning, I had some technical problems in hearing you. I didn't hear about sedimentation, about sediment. So then this is a very big issue always when we have reservoirs, so that the carrying of sediments is changed, and this is then coming through what is happening upstream, but for sure it is also then linked to what is going on in the delta itself, with blocking it or not blocking it. But is this also taking up in the model? So that is these 3 points I wanted to bring in again. Thanks.
Thank you. I think, but I also would have to check with Hester to be really sure, but sedimentation is not taken into account in the model. So the same as this blocked canals, this is not the case. The model just assumes a flow. So I think this is also a point that is really important for this, the discussion to mention. And also the reservoir management, I think it's really important because we now assumed a certain scenario where there is more water available in the dry season, but it also shows indeed the sensitivity of the flow to the reservoirs and the dams. And I think it's also, Angel, you said that yesterday to me, that if there's a hydropower dam, the chance is also increasing that this can be used for irrigation purposes, and then there's another type of management again behind the reservoir. So I think it's really important, and I think we did not include any future reservoir and dam building, and this would also be important to take into account when looking at land use, irrigation and canal, irrigation expansion and canals, but also to see what new reservoirs or dams are planned in the future and with what capacity.
But there your point, Mariana, about the reservoir management I think is key, and making scenarios in the future how those operations can change. Because what we see with the result that we have it just with this scenario is that, especially in the dry months, downstream users are completely subjected to what's happened upstream with the management of dams. No, so in our scenario they have more water available. But if you go for a dry year where probably hydropower dams release less water, probably this goes the opposite. No, so at the end is what we see is that in the dry season the river flow is mainly related with how the operation of the dams is working. So downstream users are completely or are very much related with what's happened upstream. And I think the inclusion of the scenarios will be great, can be done, but we can already see with the model that the vulnerability is there.
Okay, and so I think this is a kind of important point, right? That for the dry season, if the river flow depends a lot on the upstream, on the dams, and also what was said by Mariana, that the management of the reservoirs may be more important kind of than the land use, or like improvements that we are trying to kind of close production gaps. And though the model is not at this stage a kind of, what would I say, kind of set in stone, or kind of the results, this is all kind of still to be further checked, but this are important signals that in a way are getting from such kind of modeling, right?
Yeah, these are definitely the first steps. It was quite already a journey to make the model work and to create all this input data. And these were the first steps, but we already saw that especially towards the future, the scenarios need to be more realistic or more in line with reality.
Yeah. Okay, in that context, it's maybe also important to mention that our colleague Hester Biemans, she is actually working on a larger scale research in which she will be more kind of also working on this connection between the melting of the glaciers in the Himalaya area and then the impact downstream with crop and the water availability to such crops. So in that sense, work is not kind of final with this work what we did now. I'm seeing a hand coming. Paul, what would you like to ask?
Oh, you keep talking, everyone.
I just wanted to kind of point that out. And if people are interested in that, we can also post the link for that if people want to know more. Paul, please come in.
Yeah, I think that's a really great and sort of obvious point. It's the dams and so on. I guess if we sort of had to sort of prioritise in the sort of early or the short to medium term, then land use is going to be the thing that's sort of dynamic and the things that people on the ground are most interested in the sort of medium to longer term than dams, or depending on how quickly the dams. I think that it does sound like a big worry in the medium to long term about dams. But yeah, and so I think the land use stuff is important. And then I thought, what does it mean about the transboundary allocation of the resources? I don't know whether whether this project's involved with that, probably not, but how can these resources be used in a sort of civil way, particularly for countries like Cambodia and Laos that might be wanting to build up and use more? How can that be done sort of fairly? So yeah, I don't know the answer. It's not really, it's just more a thought than anything else. Thanks.
Yeah, no, indeed important questions. And no, the transboundary allocations are not in the model as such. And yes, I fully agree. And interesting that you say kind of like the short, medium term, the land use is something to look into, while indeed in the long term, the dams is to kind of worry about. Katie, you wanted to ask something. Please come in.
Yeah, thanks. And thanks, Paul, for your comments there too. We have definitely flagged these transboundary cooperation, particularly around natural resources, as a major area that needs to be, done with care. And I think that the thing there is that it requires sort of long-term investments and partnership to really facilitate those discussions. But my question I just wanted to clarify, is the reasoning behind why the expectation that there will be more water available during the dry season in the future is due to upstream glacial melt? Did I understand that correctly? No. Okay, can you explain?
No, I think the Mekong is not heavily dependent on the third pole. So not on the I think the Mekong Basin is more rainfall dependent, or how do you say it, dependent? Yeah, I think it's not, it's another word, but it's more depending on rainfall than on, but other, Hester is working also on all the basins that actually originate from the Himalaya range, and some of them are highly dependent on this glacier melt, which can have large effects in the future, first by a large increase of discharge and later decreasing. I don't think that will be a significant impact in the Mekong, but that's something that Hester will probably also work on, just to see how much it will be. But I think that in general, what I found in literature is that the Mekong is not depending on glacier that's at such extent as, for example, the Indus is.
And what is driving the increase in availability of water during the dry season in the future in the Mekong Delta then? Like, what's the main?
Yeah, so in the scenarios that we used, it's the lower water withdrawal because of CO2 fertilization. So that's, I think, quite still something to look deeper in how that exactly works. And because there's no irrigation increase. And the reservoir, so we have in the historic situation we had. I will show you again this graph because it's in the historic situation, which is from 81 to 2010. These are the dams that we included in the scenario, and then towards the future we also included these dams that increase the capacity. So that can have also quite a large impact on the increase of the flow. That during dry season the dams and reservoirs just let go more water. But this is something, yeah, and climate change in general can have an impact. So upstream rainfall increase during certain periods. So I think that are the three most important increases of water withdrawal during the dry season.
So Marijn, so what you're saying about that the dams that came after the historical period that you analyzed first, the dams that came after that, they have a kind of, let's say, a kind of leveling effect, that the high discharge from the monsoon gets kind of caught in the dams and then gets released stage-wise, which could then mean that could explain why the discharge is higher. So this point, actually, it will be useful to kind of check with observed data whether this would be a good explanation for why there is a higher water availability in the model, because like Katie asks, that what is driving this? Well, some of the things are assumptions with regard to future, and then we cannot really check. But this is something, because these dams already are there, we can kind of check. And of course, the model does not have the dams of the future, which are not yet there, but these are already there.
Yeah, and I think also dams of the future plans will probably already be there. The if they will be built is then the second question, of course. So that is always if the money will be there and the finance will be arranged. But I think what I would like to do with the model is to also run it once without the reservoirs, just to see how it changed. Just to see what actually the effect is of the different drivers, because now we included everything in one run, so we have to think, okay, these are the drivers, but to what extent some of the drivers support what really the effect is of each driver is not known now with this first study.
Okay, so in summary and conclusion, because we need to kind of let everybody go back to their end of the year duties soon. Thank you, Marijn, for presenting us all the details. Thank you all for asking questions that also show that modeling is giving us more insight, but also modeling provide us with more questions, which we may kind of try to address in the time to come. Like Marijn already stated, that she will continue to work on this, and also in the future program on completion of the Asian megadeltas, I'm sure you will continue working on this. Before closing this session, I like to kind of wish all the AMD and WUR colleagues a lot of success on completion, and I wish everybody a very well-deserved holiday. I look forward to continue our Delta Talk series in the next year in whatever format we can think about, but please contact me because I will certainly like to continue the Delta Talks. That's all from my side here in Wageningen. Katie, Ole, would you like to say something?
just want to thank Marin and Angel and everyone so much. And this has been a really excellent collaboration, so I really appreciate it. And I also hope that these kind of collaborative learning sessions can continue into the next programs as well. So it's been a pleasure. Thank you.
And I would like to just thank the speakers again, and also all the participants in the discussion for active participation. Thanks a lot. I'm also excited to continue the Delta talks. I'm not exactly sure in which format we'll have that, and I assume we may skip the January to establish that. But I'm looking very much forward to continuing next year. If you have any suggestions of what we can improve, let us know, send us an email, and we're happy to do what we can. Thank you very much, and see you next year.
Thank you.
Bye.
Thank you. Bye.
Thanks all. Bye.
Right.